welcome back to geometry. We're looking at lesson 68. This is Introduction to Trigonometric Ratios. So trigonometry is what we're going to look at, just the beginnings of trigonometry a little bit. Trigonometry is the study of the relationship between the sides and angles of triangles. And specifically for us today, we're going to look at right triangles and how the sides and the side lengths relate to each other. So it's sort of like Pythagorean theorem revisited and expanded. It's not the Pythagorean theorem, but it's how the side lengths of right triangles relate to each other. There's a couple things we're going to have to memorize if we don't know them already. It's just simply some memory work, and we have some memory aids to aid us, to help us in that. But there are three ratios, three terms that we talk about in trigonometry, and that is sine, cosine, and tangent. And I don't know if you all have looked at that in algebra before or not. If this is the first time, sine, cosine, and tangent. This is how they're spelled, sine, cosine, tangent. They're in the book there. You can look at them as well. Sine, cosine, and tangent. And a trigonometric ratio is a ratio of two sides of a right triangle. A ratio, in other words, we're going to call this side A, this side B, and this side C. So a ratio would be C over B, or A over B, or B over A, whatever. And it depends which angle you're looking at and what perspective you're looking at. If you're talking about this angle, or this angle, will determine how you use these. So sine, cosine, and tangent, three terms you need to get familiar with, and usually we talk about them in this order, and that's important on one of our memory aids. We'll use this order: sine, cosine, tangent. So if this is the first time you've heard these words, then say them to yourself 20 times on your own time. Sine, cosine, tangent, and get that memory, get that order ingrained in your head. All right. In a right triangle, the sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So let's say that we want to talk about this angle right here, and we're going to talk about the sine of this angle. So the sine of that angle is the ratio of the side that's opposite the angle to the hypotenuse. And you would say, well, what's the side opposite the angle? This is always the hypotenuse. We're talking about right triangles. Sine, cosine, and tangent are talking about right triangles. So you always have a hypotenuse. That's the longest side. That's the side opposite the 90-degree angle, remember. This is always the hypotenuse. And then the other two terms are opposite and adjacent. And it all depends on your perspective. What angle are you talking about? In this case, we're talking about the sine of this angle right here. So the side that's opposite that angle is A. It's opposite. B is adjacent. This is right next to this angle. We're talking about this angle, so B is adjacent. For this angle, this is the side that's adjacent. This is the side that's opposite. This is the hypotenuse. For the sine of this angle, the ratio is the ratio of the length of the leg opposite the angle to the hypotenuse. So the sine of this angle is A over C, opposite to hypotenuse. Cosine is the length of the leg adjacent to the angle over the length of the hypotenuse. So the cosine of this same angle is B over C. Again, adjacent over hypotenuse. And then the tangent, that's often abbreviated as tan. So the tangent of this angle is opposite over adjacent. Opposite A over B. Anytime you use sine, cosine, or tangent, you are always using it depending on the perspective. You're always using it looking at the perspective of this angle. I'm going to write them up here. So the sine is opposite over hypotenuse. The cosine is adjacent. How do you spell adjacent? Adjacent over hypotenuse. And the tangent is opposite over adjacent. You can further simplify that to just the letters, like the first letters of those. And right up here again. So the sign you can do it SINE or you can do it just SIN. In your calculator, my calculator says SIN, which changes sign to sin, but you still say sine. So the sine is O over H, the cosine is A over H, and the tangent is O over A. Again, these letters just stand for opposite hypotenuse, adjacent hypotenuse, opposite adjacent. Remember in your head this picture. If you're talking about this angle, if this is the angle you're concerned about, then this is the side that's opposite, this is adjacent, and this is always hypotenuse. If you change that perspective and say, okay, I'm not talking about that angle, I'm talking about this angle, or this angle, but this angle, then these change as well. Now this side becomes opposite, and this side becomes adjacent. Please remember that the opposite and adjacent always is referenced from your point of view. What angle are you talking about? All right, back to this OH, AH, OA. You could memorize that just knowing your head when somebody asks you, what's the cosine? Well, that's adjacent over hypotenuse. Or there's memory aids. The one that I'm most familiar with, and probably you all are as well, if you know it at all, it is a phrase. Oscar had a hold on Arthur. Oscar had a hold on Arthur, or has a hold on Arthur if you want to be present tense. Oscar has a hold on Arthur. It's kind of a morbid picture there. I guess they're wrestling or something, and Oscar has a hold on Arthur. OHAHOA. And then you remember that it is in the order of sine, cosine, and tangent. Now it's a little clunky in your head. You can just write it down, but if you're saying, I want to know the cosine, and say Oscar has a hold, AH, adjacent over hypotenuse. There's other terms out there that have the whole thing. They include this. So the one that I like about that is this one. You could say Saul's old horse can actually hum the Olympic anthem. I hope I didn't run out of board there. Saul's old horse can actually hum the Olympic anthem. S, sine, opposite hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite adjacent. Saul's old horse can actually hum the Olympic anthem. There's other ones. Studying our homework can always help to obtain achievement. That's about as clunky of a saying as you can get. Studying our homework can always help to obtain achievement. Another one, some old hen caught another hen, taking one away. Some old hen caught another hen, taking one away. Saul's old horse can actually hum the Olympic anthem. That's the long version. I like shorter because it's less to remember. Oscar has a hold on Arthur. You just then have to remember that it's in the order of sine, cosine, and tangent because you're not actually adding the S, the C, and the T to your saying like these big ones. This is what you're going to have to memorize. One of the things you're going to have to memorize. And also the important point of the perspective. What determines adjacent and opposite? Well, your angle. Which angle are you talking about? This angle, opposite, adjacent. If you're talking about this angle, then this side is opposite and this side is adjacent. So, depends on your angle. All right, let's keep moving. Now, actually applying that, your calculator will help you. If you have a better calculator than this one, which I hope you do. Mine says, let's see, where are we at? Sine, cosine, and tangent. The button's there. Yours have it somewhere. Find them. And look at example 2 on page 452. Turn to page 452, example 2. Use a calculator to evaluate each expression. You're going to use a calculator, and right now we're just practicing typing this in, and you'll use this procedure then to solve actual problems. But for right now, example 2, letter A, we want the calculator to tell us what the cosine of a 72-degree angle is. And if you have a 72-degree angle, right here, then the ratio of this side to this side is going to be some ratio, some fixed number when you have a 72-degree angle. Even if it's big or little, it doesn't matter. The sides are going to be in a certain ratio, and that's what this is talking about. So in your calculator, in mine, if I type in, I need to type in the number first. I don't know if your calculator you type in cosine first and then the number. But for mine, I need to type in 72 and then hit cosine. So just because we can, 72 cosine. 0.309016994. If you look in your book, it is approximately 0.31, so it rounds up a little bit. All these numbers are going to be big numbers like this. The ratio, they're not nice, neat numbers. Most of them are not. So you round it up. Next one, B, letter B. What is the sine of a 30 degree? For me, I type in 30 and then hit the button sign, and it says 0.5. So there's a nice, neat one. Just threw my theory out. Also, letter C, the tangent of a 70, I type in 70 and put tan, and it's 2.747477419, approximately 2.75. Practice this example 2 with your calculator until you can make your calculator say these numbers that are in the book. It may be that you push sign first and then the number and then equals. I don't know what you do, but practice with that until you can get it to say that, to do that, and know how to do it. Now, the way you actually solve that then is looking at example 3. Use the tangent ratio to find E, the length of E, to the nearest hundredth. So here's a right triangle. Let's put it up here so we can see it. And it looks something like this. This is E, it's the letter E. We're looking for the side length of E. We know that this is 13, this is a right angle, and this is 72 degrees. I'm going to put it outside. 72 degrees is this angle. The question is, if you go from this point and you go out here 13 inches or whatever, it doesn't say, but 13, and then you turn 72 degrees down and go back, or make this 72 degrees and go back here, you will get a point directly below this, because this is right angle, at some point. And where will you hit that? How far down here will you go? It's a fixed answer. It's a fixed number. It's only one answer, and it's a function of going out 13 inches and then the 72 degrees. So this is what we're looking for. Now you look at this problem and you say, what are my three things? Well, I have a 72 degrees here, so this is my perspective, and I have something here on this side, and I have something on this side. So which function would I use, sine, cosine, or tangent, to work this problem? Well, what are my options? I'm looking at something that's adjacent, and I'm also looking at something that's opposite. So is it A over O or O over A? Which one is it? And if you do Oscar had a hold on Arthur, then there is no A over O. So this is the one, which is sine, cosine, tangent. And I hope the book agrees with me. It says use the tangent ratio. So it told you what to use, but if it doesn't tell you what to use, which it won't most of the time, then that's how you decide. Whatever you use, sine, cosine, or tangent, which one you use is determined by what numbers am I dealing with. Am I dealing with the opposite and the adjacent, or am I dealing with the hypotenuse, whatever, that's what you use. Okay, so the ratio, the tangent function of a 72 degree angle is opposite over adjacent. Opposite is E, so we do this as the setup. Tangent of 72 degrees is equal to opposite over adjacent. And then solve for E. You could call it X or you could call it anything. In this case, we just call it E. You can use your calculator and find this, the tangent of 72, just like we did previously. But first, let's rearrange this. So if we want to do, we want to solve for E, get E by itself, we need to multiply everything by 13. Both sides of the equation by 13, or bring the 13 over here, however you want to think of it. But we're multiplying both sides of this equation by 13 to get rid of this divided by 13 deal over here. If you multiply both sides by 13, you get 13 times the tangent of 72 degrees, and that equals E, because that canceled out. Now take your calculator and say 13 times, for me I put 13 times 72 tangent, and again the tangent of 72 is 3.06, but I have to push equals to get my 13 back. So E equals 40.0098 whatever 40.01 because it says the nearest hundredth, so 40.01. Make your calculator do this, figure out how to do this, and you will have this problem licked, as long as you also remember Oscar had a hold on Arthur. Remember your orientation, which one are you looking at? Let's do one more, let's do B. Let's do example 4, that is, not B. So the top of page 453, it is example 4 on lesson 68. I hope you're with me. Again, they're going to tell you which one to use. Use the sine ratio to find x to the nearest hundredth. But you would not have to, they don't have to tell you which one to use. You should know which one to use because of the perspective. We write it up here again. We have a triangle, and it's 8, and this is angle F, and this is side x, and this is a 32 degrees. Now they say find x to the nearest hundredth. You have 32 degrees. This F doesn't really mean anything up here. I'm just going to put that there to confuse you perhaps. But again, what you're dealing with is you have a 32 degree measure, so that's your reference point. That's where you're going to be looking out to this triangle. And now you're dealing with something over here and something over here. What are these sides in relation to this angle? Well, this is the hypotenuse because I forgot to do that. This is the hypotenuse. So you have a H, and you have opposite, you have an O. So look for an H and an O, and again, it is this one. It's not that order, so you're going to be using the sine function. The sine of this angle is opposite over hypotenuse. So you just write that formula out. The sine of 32 degrees equals opposite 8 over x. Now in this case, the earlier one, the e was above. The unknown was above. The variable was on top. This time the variable is on the bottom. You still do the same thing. Now since this is divided by x, you bring x over here and say, multiply both sides by x. This is how you could do it. X times sine of 32 degrees equals 8. And then say, well, now I need to solve for x. And so since this is x times the sine of 32, you're going to divide both sides by the sine of 32 and get rid of it here. So x equals 8 divided by the sine of 32. And if you look back, all that we did is switch the sine and the x. But technically, you're multiplying both sides by x. If you just look right here, you're multiplying both sides by x to get rid of it here. That puts it like this. And then you divide both sides by the sine of 32. So this is now ready to be solved for x. So take your calculator. My calculator says 8 divided by 32 sine equals. Always push equals for me. And I get that x equals 15.09. It said nearest hundredth, so 0.9 becomes 10. So this length is 15.10, 15.10. I think that's enough to do your homework. Just review quickly. This is the most important thing right here. And if you remember, Oscar has a hold on Arthur. Two things to memorize. Oscar has a hold on Arthur, and sine, cosine, tangent, that order. Oscar has a hold on Arthur. You can get to where you do in your head or just memorize. I'm not there, but if you really like trigonometry, then you can just memorize, oh, the sine of the angle, yeah, that's the opposite over adjacent. You know that that's what you're dealing with. How you determine which one of these to use, which button to use on your calculator, is which sides are you talking about? Are you talking about the hypotenuse and the opposite? Or are you talking about the adjacent and the opposite? And then what order? Which one over which one? And you use this setup right here. And then like so. Try that for lesson 68. And our homework for lesson 68 is, lesson 68 homework is 3, 7, 13, 17, 20, 24, 28, and 30. 3, 6, 13, 17, 20, 24, 28, and 30. there for just a second while you copy it down. I guess you can push pause if you need to. Alright, do those two lessons, lesson 67, lesson 68, and have that done ready for scoring on Monday at 9 o'clock. And hopefully we can get together at 9 o'clock with some format and score.